Hey everybody, I'm James Smith. I'm the CEO and co-founder of a company called Bugsnag. And today I'm going to be talking a little bit about how to protect your applications from erratic SDKs. I'm going to go through a recent case study of this and discuss a few approaches of how to deal with erratic SDKs. So before I get into that, I'd love to talk a little bit about my background and my qualifications to even talk to you about this. So you can probably tell by my accent that even though I'm based in San Francisco, I am from the United Kingdom. I grew up in London, but I moved out here about 11 years ago to join a Y Combinator startup called HeyZap, and I was their first employee and CTO. And I've been building software in various forms, web software, mobile software, backend software for a long time now. And these days I'm mostly building a company, Bugsnag. I'll talk more about that in a second. But I've also been lucky enough to be part of the droidCon community for a long time. Bugsnag first got involved in droidCon back in 2015, and we've been part of the community ever since. You might know my work in the Android community. I wouldn't use it these days, but back in the day, I was relatively famous in the Android community for the Android async HTTP library. A lot of people called it LoopJ, which is my handle online. And this was, at the time, one of the most popular HTTP libraries on Android. I would not recommend using it these days. There are plenty of more robust, modern versions of asynchronous HTTP. So if you're not using something more modern, definitely look into upgrading. But I think of myself as a little bit of a retired Android developer. Don't ask me about all the modern best practices these days. But in general, as part of my role at Bugsnag, I get to talk with mobile developers at some of the world's leading software development companies. And to give you an idea of what we do at Bugsnag, we have built what we call a stability management platform. This is a fancy way of saying an error monitoring or crash monitoring platform plus. So rather than looking at individual crash reports, we help you figure out actually, should we even be working on crashes right now? What is our stability score? Which bugs should we fix first? Which bugs are the most expensive? So think Crashlytics, but times 1,000. And a lot of companies out there are using our product. So you've probably got a few of these applications on your phone. If you have heard of these companies, they're using Bugsnag in some form, most of them on their mobile applications. So let's get into the meat of this thing. So if you are an iOS developer as well as an Android developer, or if your team sits near the iOS development team, which I'm imagining it will be the case for most of you, you probably know about this already. Apart from everything else that's going on in the world this year, there are a couple of big outage incidents that affected massive applications worldwide. Now, I've just put a few icons here. It doesn't really matter because so many applications were affected by this. But there was an outage in an SDK that is used by most consumer mobile applications on iOS that caused most of these applications to have some kind of problem, and a lot of them crashed on boot, which is kind of the nightmare scenario. So where did this come from? Now, in this case, the culprit was Facebook's SDK. If you are building a consumer mobile application, you are probably using Facebook's SDK. It doesn't just do things like allow you to share things on Facebook. It also has authentication capabilities, and there's a ton of value for using an SDK like the Facebook SDK. The problem is, if you installed this Facebook SDK, it caused a series of crashes in applications using it. And like I said, like most consumer mobile applications use the Facebook SDK mostly for the authentication capabilities of the SDK. Now, this caused a bunch of crashes, and it was acknowledged by a lot of these applications. And again, like I said earlier, if you were developing on iOS and use this SDK, you already know about this. If you sit near the iOS team and you're an Android developer, you would have seen a lot of sweaty brows and a lot of running around and stressed out activity. But as a software developer, it's really frustrating because you can say, hey, we did everything right. We didn't create any bugs. We didn't cause these crashes. It was a third party. Well, let's figure out if there is something we can do about that. Before we do that, I want to dive a little bit deeper into how this happened. So what ended up happening was we did a little bit of an analysis and a post-mortem on this incident. Any iOS application that's using the Facebook SDK, the way the SDK works is it has to fetch some information from Facebook's APIs. And so some of the things that come back from that are, challenge response, authentication requests. If you're already logged in, it will send a bit of data back. Maybe it's going to fetch which features should be enabled on the Facebook SDK. And a lot of the settings for the Facebook SDK are configured in your Facebook developer dashboard rather than at line of code level. So when this SDK wakes up, it goes and does a request from Facebook's APIs, pulls that data back, and then interprets that data. Well, in this case, there was a change in the response, the JSON response that came back from Facebook's API. Now, you would imagine that in most cases this would be protected against, but for whatever reason, Facebook's iOS SDK did not handle this change in response well. So not only was this a bug that was in someone else's SDK, this was also a bug that happened due to a configuration change or a data format change rather than a new release of the software. Now, why does that matter? If you are a mobile developer, one of the parts of the release process is the testing rollout. You're going to run through your automated tests, you're going to run through linting, you're going to run through CI/CD, and there's a series of things that will check your application and that it works before it goes out to customers. Also, most teams will have some kind of human QA process or maybe automated QA process. So a crash at boot caused by a Facebook SDK would have been caught by these processes if it was due to a code change in Facebook's SDK. This is one of the more insidious bugs. This is a bug that was caused by a change in a response for data, which means that you could have been asleep. Your entire engineering team could have been asleep when this bug occurred, and it wasn't even in your code. So the actual code that changed was this field changed from being a hash, an object, to being a Boolean in the response. This is the name of the field here, this restrictive data filter params. And the SDK did not know how to deal with that. So what did this look like? Well, hopefully you're using some kind of error monitoring or crash reporting solution. Now, as I said earlier, a lot of people out there are using something like Crashlytics. A lot of people out there are using something like Bugsnag. In Bugsnag, this is what this would have looked like. In fact, we know this because we saw a lot of them. So it was effectively a COCO error, NS invalid argument exception. The JSON parsing code did not know what to do with this object access. So if you imagine in a hash access or object access, you're using that kind of square bracket notation or whatever. You're saying, pull me this key out of this object. But the thing that you're trying to pull a key out of was now a Boolean. And so your code went, no, thank you. And it wasn't even your code, it was Facebook's code. But Facebook's code did not know how to handle this change in response. Now, we saw pretty quickly on the Bugsnag side that there was a global outage of some magnitude. The way our system is built is that it's almost like we're receiving a distributed denial of service, right? When Bugsnag receives crashes, the devices out in the wild, the mobile phones, are detecting those crashes and then sending that back to Bugsnag. But when there's an outage like this that happens all at once, basically every single consumer mobile application on iOS that uses Bugsnag sent lots and lots and lots of these crash reports back to Bugsnag at the same time. Luckily, this is a whole other conference talk. Our system's built to auto-scale behind the scenes, so it doesn't wake up our infra team or developers in a cold sweat at nighttime if this happens. So our service is scaled up automatically. But if you were using something like Bugsnag, Crashlytics, whatever, you would have seen this in your dashboard and hopefully you would have gotten an alert about it. But actually, a lot of people spotted it via whatever means, Bugsnag, Crashlytics, and went into Facebook SDK GitHub comment and started to see the same things. So here's something that Mark Svend put into the GitHub issue. But if you were following along this live GitHub issue, it was quite chaotic. So, as you can imagine, applications crashing at boot is almost seen as the absolute worst case scenario in software development. It's very difficult to recover from that. If it was something like a button click didn't work in settings, that's kind of okay. If it was that a crash happened after doing X steps in a row or due to some particular data that you had as a user, it's not going to have the widespread impact that a crash on boot is going to have. Luckily, most good crash reporting products will report crashes on boot, but a crash on boot means no one was able to access these amazing consumer mobile applications. It kind of got a little bit more tricky. Now, this is where I'm speculating rather than having any insider data. Like, I'm not trying to anger the bug gods here, but everyone has issues like this. But in the case of the Facebook SDK, it was really hard to figure out what was going on here because the iOS SDK expected, as I said earlier, an object to come back, a hash to come back. They changed the format to return a Boolean, but according to their developer documentation, it returns a string. So I can't really figure out from the documentation what it was meant to be, but whatever the case, something changed that the SDK wasn't expecting. So as you can kind of see, eventually Facebook got on top of this. They updated their status pages and kind of filled in the details here. But yeah, this was a scary thing. So I've been talking about these two specific outages. Actually, the exact same issue happened twice. Once in Q1 and once in Q2. It was the exact same issue, so it must have been some kind of configuration change that wasn't meant to happen or was unexpectedly rolled out. But obviously, most of us in watching these talks today are probably not pure iOS developers. We're probably developing mobile apps that are cross-platform or just Android. The interesting thing to note about these outages is there's nothing unique to iOS that caused this to happen. Including third-party SDK code or any third-party code is obviously a risk. It's a trade-off you have to take. You want the functionality or features of an SDK, but you don't want to have to... hang on a second here. There we go. Sorry, I had a notification pop up midstream. You don't want to rewrite things yourself, or maybe you're using some third-party service like Facebook. You want the value that these services provide. But obviously you're including third-party code. So you're going to see this no matter what type of client-side application you're building. If you're including third-party SDKs, you're opening yourself up to the risk of failure in those third-party SDKs. So there's a risk-reward trade-off here. So what can you do about this? How can we defensively program or defensively build our applications to avoid these absolutely catastrophic scenarios? So I'm going to go through kind of a few examples here and approaches. Now, the first one, I think I would hope that more people did this, but actually talking to our customers and talking to my Android developer friends, most companies don't do this. So most companies, especially larger companies, are probably using some kind of feature flagging or experiment toggling system. This is a great way to roll out features to your customers in a phased way. If you're not using that, you're probably using something like the Google Play Store or App Store phased rollout system. But most people are adopting some kind of feature flagging or A/B testing system. Either you've rolled this yourself using something like Redis keys, or you're using a hosted service like LaunchDarkly or Split or something like this. These products allow you to turn on and off features for your customers or a subset of your customers using some kind of dashboard. Now, there's no reason why you can't utilize these to also turn on and off things in an emergency. So an example here would be for the Facebook SDK, using that as an example again, wrap the initialization, if possible, of the Facebook SDK or whatever SDK you're using in a feature flag. Now, this is definitely easier said than done. SDKs is code that you're... hang on a second here. SDKs are... Excuse me, sorry about that. SDK is code you're not familiar with. It's code that you don't understand. It's code that is written by a third party. And so it's not your job to go digging into that code, and maybe you don't understand how things are initialized. Good SDK providers will give you good documentation, and they will give you ways to turn on and off parts of that SDK. For example, you can make the initialization of that SDK contingent on this feature flag. So what would you do with that? Well, wrap the initialization of this SDK. If you noticed an outage using Bugsnag, CrashLytics, whatever, you get an alert, an email, a Slack message from Bugsnag saying something's going really wrong, your crash rate, your stability score is tanking. You can then go into your A/B testing experiment dashboard and turn off that feature. So this is the some screenshots from the incident outage page that on the Facebook developers website. So when this big red chunk came up here in May and this yellow chunk in July, you would have hopefully got alerted by using your error monitoring tool. Then you can come in and turn off the SDK, and hopefully that stops the crash at boot. Now, I said earlier it's easier said than done because of the hidden initialization logic in most SDKs. Another issue is you need to potentially re-architect your application. If you're using feature flags to turn on and off the Facebook SDK, you need to make sure that your software works without this SDK. And it's true of any SDK. I'm not just kind of picking on Facebook here. If you're using Facebook authentication and you're relying on that, and it's crashing when you boot up, that probably then means that will you allow people to load the application who aren't Facebook authenticated? Will you just allow login to fail for Facebook authenticated users? Maybe you don't use the authentication side and it's optional features like things like sharing to Facebook. You know, so let's say you're Spotify and you heard a great song and you want to share it to your buddies. You probably are okay of turning off the ability to share songs to your buddies in the case that there's an outage that would cause your entire application to crash. So yeah, you can turn on and off things with feature flags, but actually the hard part is sitting down and figuring out how to do a progressive enhancement of your software. If you've not heard this phrase before, it's can I make my software better with SDKs or whatever for people who are able to use these features? People in Android are familiar with this because there are capabilities of devices that may not be available to older phone users, and so you have to support both environments. I recommend taking the same approach with SDKs. Figure out what the essential parts of the SDK are and figure out a fallback strategy for turning those on and off. There are services and SDKs that maybe are completely essential to your application. For example, Bugsnag detects bugs in your application using an SDK. You would really hope that Bugsnag doesn't cause crashes, and in fact, that's our kind of worst case scenario. But what we've done is we've actually not only built a waterfall level of things to make sure that never happens, but also we have contractual agreements with our customers that basically say we won't screw up your application, and if we do, this is our contract with you. So some SDKs are essential. For the ones that aren't essential, try and layer in that functionality in a progressive enhancement way, and then use some kind of A/B test or feature flagging system to allow you to turn on and off these SDKs. One thing that I will say as well, because this is not necessarily an easy thing to do, you can talk to your SDK providers, especially if it's a commercial service, and say, hey, we're trying to make sure that we can turn off remote SDKs in case there's a huge outage. Can you please walk us through how to do that? If it's not in the docs, almost certainly they'll be able to help you out. Okay, so I put that first because I think that's kind of the most important thing. If something's broken, you want the ability to turn it off. So what if you can't do that? Or what if you've done that and you want to make sure that you know when there's a problem? In fact, what if you want to know when to turn it off? Well, this should be obvious, again, to most people, but you should monitor for stability issues in production releases or any releases that are in the hands of your customers. So again, I've mentioned a couple of ways to do this earlier, but probably everybody out there is using some kind of error monitoring or stability management solution. If you're not, go out and use them. There are free, Bugsnag has a free plan, CrashLytics is free, Firebase CrashLytics is free. But if you're a reasonably large company or a company that has revenue or a company that cares about customer experience, invest in a product that is professional grade. But the point is, have something. Detect when your software, your application, is not delivering the experience that you commit to delivering. So basically, any good production monitoring solution will give you probably what we call a stability score or a crash rate. You should have an idea of what percentage of your customers are seeing crashes in production. And for the ones that are really good, you want to figure out, maybe I want to look at the percentage of my users as well as the percentage of my sessions. So outside of that, you probably want the ability to dig into what caused that change in crash rate. And so, well, first off, you need to know about them. So let's set up alerting. What does that mean? Most products, Bugsnag included, has a way to help you figure out when your error rate has increased more than you expect it to. Products like Bugsnag, we've built the ability to create segments of errors. So it might be that there are customers that are more important than others, or it might be that you care about parts of the code base. So you can create bookmarks and segments inside of Bugsnag and then set up alerts based on that. But probably you want to use something like a spike detection alert. Now, we have that in Bugsnag, and what it will do is it will email you or send something into Slack when we detect an unusual increase in your error rates. So I'll actually talk a little bit about I want to talk a little bit about what to do with that information first. So sure, you get an alert. Maybe you're looking at percentage crash rates or stability scores like this. How can you actually do something meaningful with that? Well, in reality, you should have some kind of agreement between your engineering team and your product team to what you do when you're not hitting your target. And to do that, you need to set targets. So what we recommend that you do is set a couple of targets in your application. And in Bugsnag, we have the concept of your target stability and your critical stability. Now, these map to concepts like SLAs and SLOs. I'll talk more about them in a minute. But the idea is you can say, we're aiming for this stability, but if it drops below this stability, we're in big trouble. So as a product and engineering team, we need to agree that we're going to do something about that. So let's talk about the other kind of types of bug, which aren't necessarily the ones that cause everyone to see a crash. Now, Android developers are familiar with this. You know, ANRs are unfortunately a frequent occurrence in Android land, but tracking application freezes is equally important. You want to make sure that anyone who has a bad customer experience, you know about it. And so not just crashes, you want to figure out application freezes. And these can very much be caused by including SDKs. So, you know, everyone's familiar with ANRs. Bugsnag in our product, in our SDKs, we actually hook into the same signals that the Play Store receives around ANRs. We intercept these ANR signals and then capture a diagnostic dump at that point in time. So if you've done that, you can then look at the stack trace that was active when the application froze, and you can see if that was caused by SDK code, third-party code. And again, if you see that your stability score suddenly tanks, you can go one layer deeper into a product like Bugsnag and say, you know what, was that a crash at boot, or was that a freeze in ANR? And you've got that data available to you. So basically, this advice is don't just look for crashes, look for anything that's going to cause a failed customer experience. The last thing is, you know, I've said at the beginning, have A/B testing and phase rollouts and feature flagging tools to turn on and off SDKs. Actually, you probably, during the rollout of a new SDK, a new provider, you can probably use A/B testing as a way to vet them as well. So there are products that I gave an example earlier where a remote configuration change caused crashes. But actually, a lot of the times, SDKs will cause problems when you upgrade a version of an SDK. Unfortunately, you know, some SDK providers won't have the same level of QA as you'd expect, or maybe something slips through because, hey, if bugs didn't exist, our company wouldn't exist. So when they do slip through in a new version of an SDK, doing a phased rollout is really, really important. So using the Play Store's phased rollout, or using, again, something like an A/B testing experiment tool like LaunchDarkly or Split will help you figure out, did a code change in a new version of an SDK cause an issue? That's the other kind of strategy that I'd recommend. And then you can start to see things like, again, if you're using a tool like Bugsnag, hopefully you've got a view where you can look at the stability of a release. So you can say this new version that we just rolled out that includes this new SDK had a lower stability score than our previous version. That then allows you to roll back and say, okay, let's not give that version to everyone. Let's fix those bugs in that SDK. Just as a little kind of fun little thing to look at here, I mentioned earlier about the impact of a bug like this on an error monitoring provider. One of the major error monitoring, crash monitoring services actually went down due to this Facebook outage. They weren't able to process and receive every single crash report. Bugsnag was, because as I said, we have SLAs in place with our customers and we have to stay available and up all the time. This is what it looked like in that May outage. You know, error rate, pretty standard, and then a huge spike, an orders of magnitude increase in the number of crashes for these applications that use the Facebook SDK. So really, I think that Patrick Danino, who was on the GitHub issues thread of this SDK outage, really helped kind of break this down a little bit. You know, it's not just a question around, oh, Facebook did an oopsie. Everybody does an oopsie. That's fine every now and then. The question is, do you understand what your SDKs are doing? And as a development team, are you being defensive about the use of SDKs? And here's what Patrick said, and you can see all the thumbs up on this. I couldn't agree more. And I think that's a good way to think about building apps with third-party SDKs yourself. So ideally, SDK shouldn't crash your application, but if they do, you need to have real-time error monitoring and strategies in place to make sure that you can deal with it. So yeah, that's my talk. Thank you for coming, and we've got a couple of minutes left for a Q&A session now. Let's see if we've got any questions coming in. If you're using Slido, that's the way to go. Awesome, we've got a question from Jan here. No further questions. Wow, that's a good one. That's a tough question to answer. Well, I'll say the following then. If no other questions come in, you can find me on Twitter. I am LoopJ, LOOPJ on Twitter. You can find more about the product and company that we've built at Bugsnag or at bugsnag.com. We have a Twitter as well. And drop in and look for us at the conference. We are a sponsor of the conference, and we have a bunch of promotions going on at the moment. If you want to come and say hi to us, if you want to pick up some swag, have a look for Bugsnag in the conference platform. And I'll be stopping in our virtual booth for later on for any questions. Thank you for coming. Appreciate it. Thank you, Coleman. If there's any other questions as well, feel free to find me a tweet or an email. And I'd be happy to dig a bit deeper. Thanks everyone for attending. Have a good rest of the day.